Believe it or not, philosophers are in high demand. In this module I will discuss the shift from performance-centric growth to ethical, responsible and sustainable AI. Some years ago, philosophy was considered an undesirable major. Once a business professor seriously told me, "If you are majoring in philosophy, prepare for receiving food stamps." Not anymore. You may be amazed to hear that indeed many companies are hiring philosophers to develop ethical and responsible AI. Instead of collecting food stamps, now philosophers are collecting a big paycheck or even stock options. Leading AI labs like Google DeepMind, OpenAI, and Anthropic are actively recruiting academic philosophers into safety, governance, and policy roles to help determine how models behave. The unprecedented velocity of the AI revolution. This dramatic shift in hiring trends highlights a deeper truth. Society is being continuously reshaped by revolutionary technologies, from the automobile to the internet and smartphones, and now by artificial intelligence powered by massive data. However, the sheer magnitude, rapid pace, and unprecedented autonomy of AI distinguish it from all previous technological breakthroughs. This rapid advancement introduces profound ethical challenges that long-standing norms and regulations, historically serving as society's guiding frameworks, are increasingly inadequate to address in a data-driven, algorithmic world. This dynamic creates a regulatory vacuum where developers and data scientists are often operating without a map. This disconnect highlights a recurring phenomenon in human history. Our technical or rational capabilities consistently outpace our emotional, moral, and societal adaptation. This is often described to early adopters of emerging technologies with a simple but sobering statement: "Our head is faster than our heart." In technology governance, this lag is formally recognized as the pacing problem. It directly triggers the Killingridge dilemma, which posits that the social impacts of a technology are difficult to predict until the technology is extensively developed and widely used, by which time it has become so deeply embedded in infrastructure that it is incredibly difficult to control or change. Because ethical and legal frameworks tend to develop reactively and retrospectively, often only after technologies have permeated society and produced unforeseen outcomes, this regulatory lag can result in serious negative consequences, such as the erosion of public trust and the potential for reactionary, stifling policies. The horizon of recursive self-improvement. The urgency of this dilemma is amplified because AI has become uniquely unpredictable. We are witnessing an accelerating shift from traditional, human-driven software development to autonomous AI systems that actively participate in their own creation, a trajectory pointing toward recursive self-improvement. This is no longer a theoretical sci-fi scenario. For instance, Anthropic has noted that its frontier model, Claude, already authors a significant portion of the code merged into the company's own internal codebase. When software begins to optimize its own architecture at silicon speed, the traditional, reactive pacing of human ethics breaks down completely. Because a world driven by autonomous, self-improving AI introduces profound risks regarding human oversight and alignment, frontier labs are increasingly emphasizing the urgent need for international coordination. Managing this trajectory safely will require verifiable global verification frameworks and the international consensus to temporarily pause frontier development if safety thresholds are crossed. Redefining the optimization function. Should we build it? In light of these risks, the core philosophy of data science and machine learning is undergoing a massive paradigm shift. For years, the discipline operated under a performance-centric growth model, where the success of an AI system was judged almost exclusively by engineering benchmarks. Can we make it more accurate? Can we make it faster? Can we process a larger dataset? Today, The conversation is shifting from a purely technical "can we build it?" to a deeply normative "should we build it?" Artificial intelligence and big data are so powerful that their misuse or unaligned deployment can lead to severe, systemic consequences. Consequently, incorporating moral philosophy into data science is no longer an optional luxury or a postscript compliance check. It is indispensable. Modern data governance demands that models be designed from the ground up to be auditable and transparent, meaning that models should away from inscrutable black box models so that algorithmic decisions can be traced, explained, and corrected. Another goal is fairness and unbiasedness, implying that we need to actively audit training data to ensure models do not perpetuate or amplify historical societal prejudices. Counting the tangible cost. Sustainable AI. Finally, evaluating an AI model can no longer be decoupled from its physical infrastructure. The at what cost question is not merely ethical, it is ecological. The computational intensity required to train and run dense, multimodal frontier LLMs comes with a massive environmental price tag. True sustainability in AI requires data professionals to track and mitigate the literal carbon footprint of their engineering choices. This involves optimizing workflows through energy-efficient hardware, utilizing localized small language models, SLMs, where appropriate, and designing data centers with advanced cooling architectures. Shifting from performance at all costs to responsible, resource-conscious development ensures that the AI revolution does not come at the expense of our planetary climate stability. Questions for you. The above issues require critical thinking and sincere reflection. Given that AI develops at an exponential rate while policy moves at a bureaucratic pace, what practical mechanisms can data scientists implement to build proactive flexibility directly into their models before regulatory frameworks are even drafted? If recursive self-improvement eventually leads to a system whose internal reasoning is too complex for human engineers to fully comprehend, are we morally obligated to halt development? Or does responsible AI mean learning to govern systems we cannot fully look inside of? As a future practitioner, how will you navigate the tension between corporate pressure to deploy larger, more resource-heavy models for minor performance gains versus the ethical imperative to minimize the carbon footprint of your computational infrastructure? After learning about these issues, do you see ethics as an indispensable component of big data analytics and AI development? If so, would you consider taking more philosophy courses, engaging in deeper discussions about the societal implications of AI, or even pursuing a career as an AI ethicist? What do you think? I'd love to hear your thoughts. Please drop your comments here. Thank you for watching. Goodbye.